Okay, why do we care about all this? It seems like pretty abstract stuff, but it really is helpful when you're thinking about some of the calculations that we typically do in hydrology. So I want to talk a little bit about what you mean when you say we got an inch of rain. So what does that mean? It's one of those things that we all feel like we know, we understand, but how would you describe it to somebody else? How would you tell somebody, whoa, we got an inch of rain? What does that mean? Is that a lot? Is it a little? How do you know? Okay, so let's think about, instead of our area of our bucket being just a bucket, let's think of it as all of the Gallatin Valley. And as you probably are imagining in your head, that inch of rain is tied to the depth of water in that bucket, or the depth of water over all of the Gallatin Valley that represents a particular rain event. So that's what the depth is, but remember that that depth is just one component of a volume. That one L is one of the three L's making up the length cubed. So we can rewrite this with some algebra saying, well, what that depth is actually a volume of rain, a total volume of rainfall, divided by some square L, square length, some area of land. So what an inch of rain really is, and one of the easier ways to describe it is as an area normalized volume. It's a volume, length cubed, per area, length squared of rain. Now I'm going to be using negative exponents here, so hopefully that's something you're used to. I'm going to be using that a lot, so it's something that you should become familiar with. You could think of this in terms of the units as well. When you say you have an inch of rain, that means you're talking about a cubic inch of water per every square inch of the land surface. We can put this in terms of an intensity of a rainfall too. An intensity of a rainfall is usually some sort of depth per time, like you might think of inches per hour for the intensity of a given rainstorm. This gives us the chance to think about another fundamental dimension, which is time, and we can think of an inch per hour as a length per time, which looks a lot like a velocity, but I think it's dangerous to think of this as the velocity of rain because it isn't really a velocity of rain. You don't want to think of this as the velocity of a raindrop or something like that. What this really is a volume of rain per normalized area of land per time. So it's a length cubed per length squared per time. And another term for this is called a volumetric flux. So a flux is anything per area per time that you're talking about. In this case, we're talking about a volume of water. So that's a length cubed volume per area of land, length squared per time. And again, that's an area normalized volume, which is what you get for a length per time. So it's not really a velocity, it's a flux. And a volumetric flux just happens to look a lot like a velocity. We'll be talking about this a lot over the semester because if there's one thing hydrologists loves to do, it is to area normalize volumes. So a lot of times you'll see depths and depths per time for a lot of different characterizations of hydrologic behavior. So we'll come back to this again and again through the semester.